Hello friends, today's question. The torque tau on a body about a given point is found to be equal to A cross L, where A is a constant vector and L is the angular momentum of the body about that point. From this it follows that, so we have to check which of these four options, or one of the option is true, or there is a multiple true option or multiple false option. Okay, so this is basically true and false question, and it is can be multiple correct. Okay. So let us first of all concentrate on the first part, which says that dl upon dt, that is basically derivative of the angular momentum, is perpendicular to L at all instants of time. Okay. So we have to check this statement. So we know that the torque tau can also be given as derivative of the angular momentum with respect to time t. And in the given question, the torque is given as A cross L. So you can say, but torque is given as A cross L. So from here we can say that the direction of the torque, that is dl upon dt, let's see, the direction of torque, which is nothing but dl by dt, is perpendicular, or sorry, the direction of torque, that is dl by dt, is the direction of cross product of A cross L. So in which direction the cross product A cross L will be pointing, that will be the direction of torque, or we can say the direction of dl upon dt. And we can say that cross product of two vectors, the cross product of two vectors is perpendicular to the plane formed by the two vectors, is perpendicular to the plane formed by the vectors. So this is the basic property of the, you can say, cross product. So here the two vectors are A cross L, or we can say that these A cross L will be in one plane and the product will be in the another plane, their resultant, or the cross product rather, will be in the another plane. Therefore we can say that dl by dt, which is indirectly representation of the torque, is perpendicular to both A and L. Therefore we can drive the conclusion that dl by dt is perpendicular to L at all times. Okay. So we can say this statement A is true. Statement A is true. So now let us find out the statement B. And the statement B is given as the component of L in the direction of A. In the direction of A does not change with time. Does not excuse me, does not change with time. So this angular momentum L means can be divided into two components. Angular momentum L can be resolved into two components. First component will be parallel to A and the second component will be perpendicular to A. First component will be parallel to A, or we can say the second component will be perpendicular to A. And for the given question, it is given that the torque tau is given as A cross L affects only the component of L which is perpendicular to A, because the direction of the torque will be A cross L, that is perpendicular to both A as well as L, as we proved in the first part. Okay. So you can see the torque affects only the component of L which is perpendicular to A. And this component is going to change the direction only but not the magnitude. Causing it to change the direction but not the magnitude. Change the direction but not the magnitude. So as we said that only component affecting will be perpendicular, therefore we can also say the component of L which is along the A is going to affect. Okay, we can say the component of L along A does not contribute to the cross product. Does not contribute to the cross product A cross L. Okay. As because A cross A will be giving us 0. A cross A will be giving us 0. Therefore, you can draw the conclusion that the component of L, therefore, the component of L in the direction of A is going to remain unchanged. Therefore, the component of L in the direction of A remain unchanged over time. So therefore, we can say that statement B is also true. Statement B is true. Now let us consider statement C. Statement C is given, the magnitude of L does not change with time. The magnitude of L does not change with time. So let us check, you can say differentiability of L basically. You can say that the change in magnitude of the L, the change in the magnitude of L by differentiating the scalar quantity L with respect to time. The change in the magnitude of L by differentiating the scalar quantity L with respect to time t. So let's write this statement mathematically. Therefore, you can say d by dt of L dot L will be equal to, this will be twice L dl by dt, which will be giving us dl by dt is A cross L. We substitute it here and we get this as A cross L, so which is nothing but a dot product. So we can just write it separately. You can say dot product of L into A cross L, this will be equal to 0, and the reason is very simple, that because as our A cross L will be is perpendicular to L, and this implies that our dt L dot L will be equal to 0. Therefore, we can say that our L is equal to constant, or its magnitude will be constant over time. Therefore, the statement C is also true. Statement C is true. And now let us check the statement D, which states that L does not change with time. L does not change with time. can say that the angular momentum L is not going to change with the time as its direction indicated by because its direction is going to remain same. Okay, because L will be equal to, sorry, dl upon dt will be equal to always A cross L. So you can say the angular momentum vector, which is given as L, does not change with time in its direction rather, as indicated by equation, and that equation is that dl upon dt will be equal to A cross L. Okay. So what is going to happen while the magnitude is going to remain the constant? Okay, as we already proved in the part C, that the magnitude is always constant. The vector L always precesses around A. Okay, so we can draw from one conclusion that while the magnitude of L remains constant, which we proved in part C, the vector L precesses around A. Vector L precesses around A. So thus we can say the component of L along A does not change. Okay. So therefore we can say thus, although the component of L along A does not change, component of L along A does not change, the overall vector L changes its direction continuously. Overall vector L changes its direction continuously. So you can say that this statement is false. You can say statement D is false. Now, in addition to these four statements, one conclusion can also be drawn from this discussion, that is about the constant precision rate, that is WP. You can say constant rate. Although it was not asked in the question, but still we can draw the conclusion from here. So which basically means that rate of change of angular momentum vector, that is L, rate of change of angular momentum vector L, it is given in magnitude by, is given by the magnitude vector and this will be governed by the equation that tau will be equal to A cross L will be equal to A L and sine of theta, where theta is the angle between A and L, where theta is angle between A and L. And since A is constant, the L will be also constant. Since A is constant and L is constant, therefore we can say the precession rate, therefore the precession rate, which will be given as WP or represented as WP, is equal to magnitude of torque divided by magnitude of angular momentum. We substitute the values, we get A L sine of theta divided by L magnitude, and this gives us that precession rate WP is equal to A sine of theta. And we already said that A is constant, so you can say as A is constant, therefore our WP, or with respect to theta also we can write that A is constant because L precedes uniformly around A and maintains, and thus maintains a constant angle theta between the two, and thus maintains a constant angle theta with A. So therefore we can say that omega p is also constant. So this completes the question. Let me mark it here. So we have A will be our true, B is also true, and C is also true, but D is our false. Okay. So this completes the question. Thank you.